Hi everyone, welcome back to another Python episode of \n. Today we'll be covering syntax and variables. Syntax is how you write a programming language, and Python has a very specific way of writing its code. The main thing you have to think about with Python syntax is it's all about indentation. Different levels of indentation mean different things. In other programming languages, things like the semicolon play a big role, but in Python that's not there because it wants to be able to be read easily. We've already seen some of this in the previous videos. If we look at a function definition like this, so we have our function that returns 1, we see here that the code inside the function, so the return statement here, is indented. See, 4 spaces. So this means that this code essentially belongs to this function and will only execute when it's inside this function. I'm not going to get into all the details of functions specifically because that's not what this video is about, and we'll cover that in a later episode on functions themselves. But for now, all you need to know is that when code is indented like this, so these 4 spaces, it means that this code will only happen if this line is essentially true or executes. So this return 1 statement will only happen if this function definition is actually used. And in our case, we saw this in the last video where the function was called. We see this in other control structures in Python, such as loops. So a simple loop in Python is we can loop through 10 values and we can print them out. So here we see we've got our for loop, and then the print statement is again indented, showing that it actually belongs to this for loop and it'll only be executed if this for loop executes as well. We will cover for loops and some of the other control structures of Python in a later video. We can have a look at this for loop to show some things about the specific syntax. So if we delete this function definition because we don't need it. Now, if we look back at our previous video on executing a script, we simply type Python and then test.py and it should execute our script. So what this for loop does is essentially just prints out the numbers from 0 to 9. Pretty easy, right? Because this is written correctly. Now, what we can do is we can have another indent. So if we hit tab or we use 4 spaces, we can see what happens when there is the incorrect syntax. Now, this would be incorrect syntax here because there's actually 2 indentations rather than 1. So we get to this when we have nested loops, for example, but this is incorrect for a single one. So these lines in VS Code actually make it really easy to show you where your code should be. The thing about this, if we have a look at how this actually works, is that it will actually still execute, which is because Python is very forgiving. And this is also something that can be quite bad because you can actually have a mistake in your code that you don't realize and accidentally cause some unintended consequences. So for now, just remember everything should only be indented once under the above thing. We're not limited to just one thing that's being indented. Everything that's under the indentation will also be executed. So we can write the same statement again here. If we get rid of this and then run our code, we see here it prints every number twice, see 0, 0, 1, 1, 2, 2, because it's executing both of these functions here. So again, you're not limited to just one thing that's under each indentation. You can have as many as you need and you can keep going. Now, if we were to indent the second print statement here, we can see that Python doesn't like that. And VS Code's really good because it goes red and says you've got an error here. So the error is here and unindent not expected, right? So essentially this is me having this Pylance extension saying, hey, this doesn't look right. Okay, so we can actually see what this looks like if we run our script again and we get an indentation error. All right, so this means that something's gone wrong and our indentations don't make sense because this print statement here doesn't need an indentation after it. It's just a print statement. And we'll go through this when we cover functions in a little bit more detail because it's a built-in function. But for now, you can see here, VS Code's really useful to highlight exactly where something has gone wrong. We can also see the reverse. So if we remove this print statement and we actually delete this indentation here, you can see that there's another error. So if we run our script now, we can see here again another indentation where this for loop is expecting to have something inside it, you know, for something to be indented, but there's nothing there. So this again is incorrect. And these are errors or exceptions that get raised. And we'll cover this in a later video covering exceptions as well. But for now, all you need to know is when something like this comes up, this is an error, something's gone wrong in your code and you need to fix it for it to work properly. We can also have syntax errors in our code. So if we delete this and go back to our original function definition here, that returns 1. And if we were to say this, look, all good. Now, but if we delete this semicolon here, we see here that now there's an error. And because Python is saying, hey, there should be a colon there. And if we run this, we get a syntax error saying, you've written invalid code. Python doesn't know how to translate what you've written into code that it's running, essentially. Because at the end of a function definition, we need to have a colon. So when you see something like a syntax error, it pretty much means you've typed something wrong and you need to go back and have a look. And if we just go back to that here, again, VS Code and Pylance as the extension shows you exactly where something's wrong. And here it says there's 1 error, which is good. And on the right hand side, you can actually see it actually shows you whereabouts. So if we had a lot of code, like many lines of code, you'd be able to quickly go to where the red bits are and say, this is where it's wrong. That's pretty much the basics of Python syntax. It's very user-friendly. It's very readable. We will be covering more and more things in other videos, essentially, so you understand things like the function definition that we've got at the moment or the for loop that we went through earlier. So you don't need to worry about too much about those at the moment. Just think about if you've got something like a function definition or a for loop, things should be indented inside it. And Python will tell you where it's expecting an indent or where it's not expecting expecting an indent and something weird has gone on. The second part of this video is all about variables. So let's get rid of this. So variables are essentially very, very important in Python and in programming in general because it's where you assign values to something to be reused. Let's assign a very simple variable. So here we have the variable a, and let's assign it the value 1. Now, if we use the value a, so here let's have a print statement and we print a, let's have a look at what comes out. So here we see down the bottom, we print 1 because we've assigned the value of 1 to a. The same way that we could have b and we could assign the word hello here, and we could print both a and b. So let's have a look at those, and we get 1 and hello. Pretty easy, pretty simple there. This first one is an integer, this second one is a string. So this is a number and this is a word, and we'll cover integers and strings when we get to data structures in a later video as well. But for now, we're looking at the variable assignment. The thing about variable assignment is it's super easy. All we do is use the equal sign. So this says a equals 1. So in English, that means let's assign the value of 1 to the variable a. And the second one says let's assign the word hello to the variable b. Super easy, okay? Sometimes it will be simple like this where you'll be assigning a value, but in other cases, a value could be generated automatically by the program or by some other system, and then you assign it to a variable in Python for you to use. So variables are really, really important. There are a few things you need to think about as well though, because variables can be overwritten. So in other languages, this behavior is not always common and variables cannot be overwritten, but in Python you can. So let's keep our example where we just say a is equal to 1. Actually, side note here, you can see here, we've got an error here. So b is not defined. So I'm trying to print a variable that doesn't exist, right? Because I've just deleted the b equals hello. So if I run this, we get a name error, and essentially it says, you've tried to use a variable here. We don't know what this variable is, okay? So that's also something to keep an eye out for. So let's delete this b, and if we go back here, we should just see the 1. But what happens here if we go a equals 2 here, and then we print a here, right? So let's run this. So the first print statement happens, which prints a equals 1, and then the second print statement happens here, where a is 2 now. So this is something you need to be very, very careful as well, because you can overwrite variables with other values, often accidentally. You don't realize that you've already defined. Maybe I forgot that I defined a as a variable at the very top, and all of a sudden by here I've realized I just need another variable. I've called a again, and it happens. So variable names like a, b, c, x, y, z, I, and j, these are really common single letter variable names that people use, and often it's very easy to overwrite something that you were keeping in a previous part of the code. My advice here is to use really complex, or I wouldn't say complex, but extended variable names saying exactly what it is. So for this, it'd be something like my number here. So then I know exactly what it is. So if I print here, it's fine. I've got my number, and I know my number is equal to 1 because that keeps track. And when I go back to look at my code, I know, okay, I know exactly what this variable is. One thing about overriding variables and the syntax in general, right, is that Python is case sensitive. So if we change this to a capital A, not a lowercase a, and then here we printed a and had a look, we see here that lowercase a is 2 and capital A still is 1. So in Python, all of the variables are case sensitive. So this capital A and this lowercase a are completely different variables. And that's really important to keep in mind as well. There are some conventions. So normally you would use capital letters for global variables. So those are variables that are defined essentially like this one, outside of any functions right at the very top. And normally the rest of your script would be within functions, and variables that you define within functions would be lowercase. There are a few different ways to define variables. So you have things that we looked at before, like my number. So this has the underscore between the words, or you have things like my number like this, which has got capital letters to show the start of each new word. So both of these are completely fine. My preference is to use this. This is a much more Python way of showing variables. This is a lot like Java or JavaScript. There's different preferences and different style guides depending on what sort of code you're writing. But if you're just writing code for yourself, pick something that you're comfortable with that makes sense. Personally, my preference is to use the underscores. I think it's a lot cleaner, a lot easier, a lot neater. Another thing about variable assignment, if we get rid of all of this, is that you can do multiple at the same time. So say we had x, y, and z, and we could assign it to 1, 2, 3 here. So now if we print x, y, and z here, we see that it's 1, 2, 3. So x is 1, y is 2, and z is 3, right? So say we just printed y, z, we should just get 2, 3, right? So if you've got a whole bunch of really simple variable assignments like this, you can do it all in one line. And I wouldn't recommend to do this for more complex things, but for an example similar like this, super easy. Maybe you want to generate a whole bunch of numbers that are all 0, sort of like this. So you can see here, it's very easy to do that just on one line. And then you can easily tell the person reading your code or the user, they can have a look look and go, yep, they're assigning all of these variables to be 0. That's easy. I know what that line of code is doing. The only thing you need to keep in mind when assigning variables is there are some reserved keywords. So for example, to define a function, we write def. So if we wrote def equals 1 here, and then we ran our code, it'd have a syntax error because it says it's trying to define a function, but we've got an equals sign. So this doesn't make any sense. You can't use a reserved word and assign it as a variable. And if we have a look here, so this is the real Python website, here are all the reserved keywords. So here we've got def, and we will cover a lot of these keywords in other videos as we go through them. So here's the for and the in that we use when we were giving the example about the for loop as well. So these are sort of the Python keywords that do specific things, and you can't assign keywords to be variables essentially because Python has a special use for all of those words. That's going to be it for Python syntax and variables. For variables, the next stage of this is looking at things like types and casting. So where I said integer and where I said string earlier, but we're going to cover that in another video because I wanted to keep this nice and short where we just give an introduction to sort of what the syntax of Python looks like and how to assign variables, which are really one of the core functionalities of the language. It's where you can assign things to be able to reuse them later and not having to rewrite code, which is really, really important. So thanks for listening to this episode of /n, and I hope to see you in the next episode.